in order to understand why atoms bond, we first have to look at the octet rule. The octet rule states that within an atom, it is most stable if all of its valence electron slots are filled. There are usually 8 valence electron slots, except in a few more complex cases, and therefore it's called the octet rule, where oct means 8. So first of all, valence electrons. If we use the primitive model of having an atom as just having little rings of electrons around it, you have a bunch of different rings at different energy levels. That is, they have different amounts of energy in the electrons, and therefore different distance from the nucleus. The valence electrons are the electrons in the outermost energy level. So in this case, this here is the valence electrons. So, what this means is that if we had an electron here, an electron here, an electron here, this atom, whatever it might be, it has 3 valence electrons. So, the octet rule would state that this atom would only become stable if it can somehow gain 5 more electrons or lose 3 electrons. So, the next thing that we have to deal with here is how would we get this? How would we suddenly stabilize the elements? And this is why the octet rule is interesting in chemical bonding. If we start with the Lewis diagram, say the Lewis diagram for carbon, which looks like this because it has 4 valence electrons, what we basically have is a symbol in the middle and a dot for each valence electron. So this has 4 valence, and obviously it now needs a lot more in order to stabilize itself. So what we can do is have another carbon here, and what we basically end up doing is that we can draw a line between the two of them to stabilize each one. And now this, so what basically happens is that this electron is part of this one, and this electron is part of that one and that one. I'm going to redo this a bit, just so it's clear when we actually get to the Lewis diagram. So, basically, you get the effect of having 1 more valence electron on each side. And as it turns out, it's kind of difficult to properly do a carbon diagram, but it's just easier to draw. However, to show properly Lewis diagrams, let's use oxygen. So oxygen has 6 valence, which I'm going to tell you right now is easier to work with. And so oxygen has 6 valence. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 and 6, so we need to get them both to 8. So if we say bond these two together, this becomes the effect of 7, and this also becomes the effect of 7. If we bond these two together, this becomes the effect of 8, and this also becomes the effect of 8. And so this is the Lewis diagram for an O2 molecule, which is just the everyday oxygen that we breathe in. So now the thing that we have to note is that this is only one of a few types of bond. This is the covalent bond. In a covalent bond, the octet rule is fulfilled by sharing electrons, which is why we draw the lines between them. And this way of looking at the atoms, which only works for covalent and ionic bonds, is called the Lewis diagram, which is where you have, which is where you use dots and lines to represent electrons and bonded electrons, respectively.